This is our video 5 on circuits, and we're gonna solve a lot of questions with resistors and circuits with the resistors and resistors. And when we did these type of questions in AP Physics 1, we looked at Ohm's law formula, where V is equal to I times R. And we did talk a little bit about what the resistance is. So the resistance depends on the material. So the resistance will depend on the material. This is where rho, the resistivity, comes from. And then it will depend on the length of the resistor and the area of the resistor. So the longer the resistor is, the more resistance it will have. So the resistor is linearly proportional to the length of the resistor and inversely proportional to the area, because the bigger the area, the easier it is for the electrons to move through the resistor. So resistor is the resistance of the electron flow. It depends on what material it is made. So this is the resistivity of that material. Depends what material you choose. The length of the resistor and the area, the cross-sectional area of the resistor. And then you have conductivity. It's the opposite of resistance. Conductivity is how well the conductor allows the electrons to flow, and it's the reciprocal of the resistivity. So conductivity is how well the conductor allows the electrons to flow, and the resistivity is how resistant the material is for the flow of the electrons. Resistivity is measured in ohms times meters. Resistance is measured in ohms, and the conductivity is 1 over ohm times meters, or ohm to the negative first powered over meters sometimes, or ohms to the negative power meters to the negative power 1. And then we also have a new formula that I want to look at, and this formula is called the current density. So if you want to know how to calculate the current density, or they ask you to calculate the current density, it's the letter J. It is amps per meter squared, the units of measurements. So letter J is the current density. It is how much current flowing over specific area, and measured in amps meter squared. And then you see the picture of all different types of the resistors, and the different colors mean the coding for the value of the resistor, and there are tables that represent what each color means and what it stands for. If you are ever taking our digital electronics class, you will be learning the resistor coding in that classroom. And many times when I give you problems with the resistors, usually I give you the problems that not real resistances, but I want you to just know how to calculate the total resistance of the circuit, the current or the voltage drop on the resistor. But the numbers I choose for you in our problems that you will see, they are not the real numbers, but easy to calculate, so you understand the process of calculations. But in real life, the resistors have different values. Let's look at one of the first questions that we're going to solve in this video. And this question says, what is the resistance per unit length of a 22 gauge nichrome wire of the radius 0.3 to 1 millimeters if a potential difference of 10 volt is maintained across 1 meter length of a nichrome wire? What is the current in the wire? And then if the wire is melted down and recast with a twice the original length, so we have twice the original length, find the new resistance. So Rn is the new resistance as a multiple of the old resistance, and R sub 0 is going to be the old resistance. So the new resistance and the old resistance. To solve the first question, to find the resistance of the resistor or the gauge nichrome wire, I need the formula R is equal to the resistivity, and then we have the length over the area, and it is nichrome material, so it's 150 10 to the negative 8 ohms times meters. So I have 150 10 to the negative 8. The length is given 1 meter. So if the potential difference 10 volt and maintain across 1 meter length, so we have 1 meter. And then the area is it's pi r squared, pi, and the radius is given 0.321 10 to the negative third, and all of it squared. So the resistance is equal to 4.63 ohm. So this was part A. For part B, they ask you if the potential difference is 10 volt and is maintained across 1 meter length of the nichrome wire, what is the current in the wire? So the current is equal to, from Ohm's law, it's the voltage divided by the resistance. The voltage is 10 and the resistance is 4.63. So that will give me 2.2 amps. And for C, the last part, they ask you the wire is melted down and recast with twice its original length. So I have the resistivity. To find the resistivity for the new resistivity, the resistance is equal to, so it's the same resistivity, it's the same material, and then you have twice the original length, but it also will change the radius. So the volume of our wire used to be, the length was 1 meter times the area. So that was the volume, not the voltage. That's the volume. Maybe I'll do it like this, the volume. The length was 1 meter, and the area was pi and r squared, which is 0.321 10 to the negative third, and all of that squared. So the volume I used to have is, let's do original volume, was equal to 1 times 10 to the negative 6 meter cubic. And what they did now, they did twice the length. So the new volume has to be the same as the original volume. So the new volume is equal to the original volume because it's the same wire. But what you do is twice the length, and the area is new, and it has to be equal to the same 1 10 to the negative 6 meter cubic. So the new area is equal to, the original length was equal to 1, so it's 2 times 1. That means the length of the wire is now 2 meters, not 1 meter. So the area is going to be equal to 0.5 10 to the negative 6 meters squared. So right here I have 0.5, the original. So this was original, and your new area is 0.5 of the original area, because in order to change your volume, not to change volume, when you change the length, your area becomes 1/2 of it. So that is 1/2 of the area. So that gives you 4 times the initial resistance. So this was initial resistance. So if you have 4 times the initial resistance, and that's what they ask you, so what is the new resistance? It's 4 times the initial resistance. Let's review how to calculate the total resistance and finding the current in each branch, like I1, I2, and the total current. and then the voltage dropped on each resistor. So what I see first when I look at this question is that these two resistors connected in series. Because they are connected in series, I can redraw this circuit as this one is still 6 ohm resistor, and the other two in series, they can be added, so that is 12 ohm resistor. I'm replacing those two resistors with one resistor, and then I have another 12 ohm resistor, the last one, and all of that is connected to the battery. Let me call this point A and this point B. So here I have A and B. So this point, these 2 points. And now I have between 2 points, let me make the choices. This one is longer and this one is shorter for the battery. And I'm going to write this is 12 volt. And I knew that the top one was longer because the current that they show is going in this direction. So this is your total current, or the sum of all the currents together. So for this question, I have two resistors in parallel, the 12 ohm resistor and another 12 ohm resistor. Because they are in parallel, I can do 1 over, the result flip over. So I have 1 over 12 plus 1 over 12. It's 2 over 12, the result flip over is going to be 6 ohm. So I can replace these two resistors with one resistor of 6 ohm. So now I have, instead of those two resistors, one 6 ohm resistor. Here is still A, and here is still B. I just don't have those two resistors in parallel. And then I have the 6 ohm resistor, and this one we just calculated 6 ohm resistor. So this is the one that we just found, 6 ohm resistor. Here it is, 6 ohm resistor. And I still have the battery, which is 12 volt. Now two resistors are connected in series. So because they're connected in series, I can redraw the circuit again. I'm gonna add them together. So when they're connected in series, all I have to do is just add them. So I have 12 ohm resistor instead of those two 6 ohm resistors. And the battery is also 12 volt. So I know that the current that is leaving the battery, and they call it in their circuit IT, the total current, is equal to 1 amp, because the current is equal to the voltage divided by the total resistance. In our case, we have the voltage of the battery divided by 12, and that gives you 1 amp. So now I know that this part is 1 amp. So here I'm going to write an original problem. So this is 1 amp. When it gets to point A, some of it is gonna go that way and some of it is gonna go this way of the current. So this is where you see I1 and I2. I'm gonna calculate how much voltage is dropped on the first resistor. So how much voltage is dropped right here on the first resistor? So it's I times R. I is 1 and R is 6. So there's 6 volt dropped on the first resistor. So when you have, I call them aliens, amps, when you have them leaving the battery, so the current is starting leaving the battery, there are, in our case, we have only 1 amp running, and by the time this amp gets into point A, it will have to split between these two. So when he passes the first resistor, he had $12 in his pocket. So he will have to spend $12 before he gets back home to the battery. So here he said he's going to spend 6 volt. So what's left between point A and B, so the voltage between A and B is also 6 volt. That means the voltage between this point and the voltage between that point is also 6 volt. because if the current is leaving the battery, it passes through this resistor, gives 6 volt away, and then passes through these two resistors, gives 6 volt away, and then comes back home. So between point A and B, it will be losing 6 volt of potential difference. If he chose to go that route, he also would give 6 volt away. So it doesn't matter how he chooses to go between A and B, through those two resistors and back home, or through one 12 ohm resistor and back home, still loses the same 6 volt. So I cleared a little bit my image. So I have 1 amp is coming, and then I have 6 volt drop on the first resistor because I can calculate the voltage by V is equal to I times R. My current is 1 amp we calculated, the resistance on the first resistor is 6, and that will give me 6 volt. So that's how I know the top voltage is 6 volt. Then we said between point A and point B, another 6 volt is going to be dropped. So because between point A and B there is another 6 volt. And so when the current gets to point A, some of it is going to go through I1. It's going to be called I1, and the other one is going to be called I2. I can calculate I2 right away because the potential difference between two sides of the resistor, 12 ohm resistor, is 6. Then the current on the fourth resistor, so I2 is equal to the voltage, which is 6 volt, divided by the resistance, which is 12 ohm. So the current right here, I2, is going to be 0.5 amps. So you had 1 amp leaving the battery, and 0.1 amp went this route. Then you know that another 0.5 went that route. So the current right here through these two resistors, also 0.5 amps. Because it's 0.5 amps, then I know how much voltage is dropped on this resistor, the top one, 0.5 times 8. So again, it's I times R. Current is 0.5, the resistor is 8. So this is 4 volt is dropped on this one. And then to calculate the voltage dropped on the second resistor, again, it's the current times the resistance. The current is 0.5 and resistance is 4. 0.5 times 4 gives me 2 volt. So you see between point A and B, you're going to lose 4 volt on this resistor, and then you lose 2 volt on the second resistor, and the total voltage you lose between A and B is still the same 6 volt. Let's look at the next example. In this example, I have 2 resistors. I'm going to place them in the same box. 2 resistors in parallel. So I'm going to get rid of these 2 resistors first. So every time I have a circuit and I see 2 parallel resistors, I'm going to get rid of them. So instead of those 2 resistors, I'm going to have 1 resistor. And I'm going to calculate what it is equal to in a second. Then I have the 10 ohm resistor is still there, so I have 10 ohm resistor. Then I have the battery, which is 6 volt, and back to the 1 resistor that I'm going to just calculate right now. Let's call this point A and this point B. Between A and B, I have 20 ohm resistor connected to 20 ohm resistor. So calculating the total resistance of 2 parallel resistors. So if they're connected in parallel, I have 1 over 1 over, the result flip over. So I have 1 over plus 1 over. The common denominator is 60. So I times the top and the bottom of the first fraction by 2. And I get 3 over 60. So the result has to be flipped over. So the total resistance is 20 ohm. Now I'm going to look at these 2 resistors. They're connected in series because they're sitting on the same line. So right here, the same line. These like sharing the same pipe where the current is going to flow through. So to calculate their total resistance, I'm going to go to a different place. So we went that way, and then we're going to go this way. So instead of those 2 resistors, I can place another resistor. Because they're in series, I just have to add them. So that is 30 ohm. And then I still have this resistor with 20 ohm, and I have the battery, which is 6 volt. Now I have them in parallel, and because they're in parallel, I still could find their total resistance. So I would have 1 over 20, because they're parallel, it's 1 over 1 over the result flip over, so 1 over 30. The common denominator is 60, so times the top and the bottom of the second one by 2, and times the top and the bottom or numerator denominator of this first one by 3. So that gives me 5 over 60, and the result has to be flipped over. So I could rewrite this final result, or final graph to the circuit, by combining these two together and making this one resistor, and this one resistor is going to be 12 ohm. And the battery is 6 volt. So to go from the previous circuit to the final circuit. From here I see that the current is going to be I is equal to V over R. From Ohm's law, V is equal to I times R. So you have 0.5 amps current. So I know this current is 0.5 amps, or this current, the one that is leaving the battery, is 0.5 amps. Then to find the current over here, because they are connected to the battery, so the voltage between A and B is 6 volt. So 6 divided by 20 gives me 0.3 amps. And because you had 0.5 amps leaving the battery and 0.3 amps went through 20 ohm resistor, then 0.2 amps will go through the second resistor. So here you have 0.3 amps, and that way you're gonna have 0.2 amps, and let's just confirm that it is 0.2 amps. So between point A and B, the voltage is 6. 6 divided by 30 will give you 0.2. So again, leaving this battery, I have 0.5 amp current. This current is 0.3 amps, and that current is 0.2 amps. Then I see how much voltage is going to be dropped on this resistor between those 2 points. So I times R, it's 10 ohms times 0.2 gives me 2 volts. And I know that between point A and point B, you have to, let me do it in red color, between point A and point B, you have 6 volts because it's connected to the battery. So you lose 2 volts on the first resistor, 10 ohm resistor. That means you lose 4 volts between the other 2 resistors that are connected in parallel. So you lose 2 volt here, and you lose 4 volt here, because between point A and point B you have 6 volt because it's connected straight to the battery. So if you know that the voltage between these 2 points is 4 volt, then you can divide 4 by 30 to get this current, and you can divide 4 by 60 to get that current. So 4 divided by 30 gives me 0.133, and 4 divided by 60 will give me 0.066 amps. So I have 0.133 amps, 0.066 amps. If you add them together, and it's 6 repeats and 3 repeats, so if you add them together you get 0.2 amps. So because you have 0.2 amps, it goes through the first resistor, and then it splits between the other 2 resistors. Let's look at this example from our lessons online. So we have 0.3 meter wire, length wire, and with a uniform cross-sectional area, the area is given and potential difference is applied of 5 volt across it, producing the current of 2 amps. So they ask you to find resistance and then resistivity of the material. So to find the resistance, I will use Ohm's law, that's the voltage divided by the current. The voltage is applied 5 volt and produces the current of 2 amps. So the resistance of the wire is 2.5 ohm. And I know that the resistance is equal to the resistivity, the length divided by the area. And so if I plug in this is equal to resistivity, I need to find the length. They give you 0.3 meter, and the cross-sectional area is 10 to the negative 5. So the resistivity is equal to 2.5. So I set these two guys equal to each other. This is equal to this. Multiply both sides by 10 to the negative 5. And then divide by 0.3. And that will give me 66.7 10 to the negative 5th. And it is measured in ohms times meters. I will end our circuits 5 video here, and in the next video I will solve a lot of questions with circuits and resistors in them and different types of circuits, and explain how to calculate the total resistance and the voltage drop on every single resistor. So the next video, number 6, is going to be a lot of circuit practices. And thank you for watching this video, and I will see you in the next one.